Hi, everybody. I'm going to be taking you through the first problem here, 12.2a worksheet on linear transformations using logarithms. So this first page you'll see here is just there's no work needed to be done here. This is just a page of graphs to help you understand. There are three different regressions that were run: price versus age, log price versus age, log price versus log age. So if you saw the video already, you know that this first one represents a linear model, this one represents an exponential model, and this one represents a power model. These are Minitab printouts here. So just like in the past, that is the intercept and this is the slope. Same thing down here and down here as well. The difference is that when you actually make the equation with these second two, you have to remember to include logarithm in the equation itself. So it would be like log price equals then these coefficients. And over here would be log price with these coefficients and then log of age as well. All right, so let's get to the questions here. The first question, explain how the information provided suggests that a linear model may not be appropriate for describing the relationship between car and price. Let's take a look at the three R squared values up here. So this first one, come on over here, Bubble. Oh, okay, Bubble's not going to go. This first one has an R squared value of 89.3. This one has an R squared value of 97.7 and 92.3. Out of those three, we can clearly see that this one has the lowest R squared value. That is one indication. A secondary indication is this residual plot. The residual plot has a clear U shape, and this is representing the linear model. So that's why my answer to this question, the linear model is the first regression up there of the three. So the linear model had the lowest R squared value of the three. In addition, the residual plot showed a clear U-shaped pattern. These two things combined means that the linear model is not the best model. Second question. Would an exponential or power model provide a better description of this relationship? Use the information provided. So now it comes down to these two models. So let's see which one's better. The R squared value of the second one is better than the R squared value of the third one. It's closer to 100%. Secondary piece, let's look at the residual plots. This one doesn't appear to have any clear pattern. This one kind of does. It looks like it's an upside down kind of U-shaped pattern there. Out of these two, this residual plot is definitely better, and the R squared value is better there as well. With those two things combined, that is telling us that the second regression is the best one, has the highest R squared, and the residual plot shows no clear pattern. Because this second one is log of y versus x, as opposed to log y versus log x, this second one is an exponential regression. So what this tells us is that the model is an exponential model. Question 3, give the actual equation. So this is where we use that Minitab printout here. Notice I have log of price is equal to 1.43723 minus 0.090652 age. I did not put log of age because the second model does not take the logarithm of the ages. These two numbers that are in this equation were from this Minitab printout right there. So I just put them in the proper places, intercept and slope. And was sure to put log in front of price since that's what the graph was of. Number 4, use the model to predict a 5-year-old Ford Taurus. So we plug 5 into the problem, the equation that we just got in number 3, and end up with 0.98397. Now, the next step, you're going to have to remember a little about logarithms. Log means log base 10. So in order to isolate the price here, you have to use logarithm to change using logarithms to get the answer. It would be price is equal to 10 to the 0.98397. Some of you may have learned like the fishhook thing, or just know that this is the base, that's the exponent, and then this is the output of price hat. When you put this in the calculator, we get 9.6376. This whole time, if you look at the directions at the beginning, the y values were in thousands of dollars, and therefore the total answer is $9,637.62. So I hope this helped and that you understand how to do all these questions. Email me if you have any questions. Thanks for listening.